Hello everyone. And this video, I will show you about how to use the building machine generation model based on the Subtractive algorithm. This model is a little bit different from the addictive one because this model is more suitable for the more constrained or restrict design condition. For example, you have a predefined building volume, and this is much more suitable to use the subtractive model than the additive model. So in this video, I will show you some major function and operation of using this model. So as you can see, you can find the components in the EvoMass tab, and then you drop here, and the basic the operation is you click the set parameter, it will generate a default building meshing, and then if you want to change this to generate some random design variants, you can click the shuffle meshing, and then it will keep generate new design solution design variant based on the setting. So the most important, so I will explain this setting step by step, and you will know which one you will use when you define your own model. So the most important one is this three, is define the basic or the maximum volume of the building meshing. For example, here is a 20, it's actually the column grid in the X direction and the column grid in Y direction, also the floor number. If you change this, it will define the maximum model volume of the building. For example, if change to 10, it would be like a rectangle, or a cubic, like a building volume. And if you, for example, set here to A6 or 20, you will get a high-rise building like this one. Yeah, so you can define this parameter to customize the algorithm to satisfy the design condition. And the second quite important parameter is this subtractive number. This subtractive number defines how many voids can be created in this generative model, because this model is supposed to generate some design solution features, some passive design strategy like the courtyard or the A-train. So I define two types of the subtractive. The first one is they can cup the building from the top to the bottom, and the second one is cup the building in the horizontal direction. So if, for example, you can change these two numbers to base according to your requirement. For example, if you set this to 0, there are only vertical subtractor will be show up in the generated design, and in this case, the building will only features like the courtyard and the A-train. So in the contrary, if you set this to 0 and set this to any number, and then he will generate some like the cascading roof or some other types of the sky garden or the steel in the building meshing. So you can change this number to create the design you want to, or create the design space you want the optimization algorithm to explore. So okay, there are still some bug I didn't find, and here and the other two important is this set of the parameter. His can help you to define the size range of this subtractor. For example, if you make this a little bit larger, this hole will be become larger, and also you can set here. And if you want this to be a smaller, you can also define a smaller size range for these subtractors like this. And I forgot to say that there is another two parameters very important. It's the floor height and the span size. The span size means the spacing of the two columns. So if you change this, for example, to 6 meters, the building will be a little bit smaller, and this can also change the floor height and to satisfy your need. So we change to the default number here. And of course, you can generate the core. The core means the structural core or the core for the circulation. This will be automated calculated in the center of the building, because in some cases, for example, the high-rise building, usually they will preserve a space for the circulation and the fire evacuation. But it will cost you a little more time to compute the whole geometry. So to make sure if you want this function, you click this the box. And all right. And the other two, other useful, the next function is the set the target gross area, because the gross area is usually have to be considered in the architecture design. So you don't want the generated building have a exceed or too small than the target area you expected. So you can define your own expected target area when using this model. So for example, let's see how many of the target area of this building. Here is the 48,000. So let's see, we can set here to the 50,000 square meter. So after you click this one, the building will be automatic change the size of this subtractor to make the generated design have satisfy gross area. So you can check here is 48 is already. So change the building design a little bit. Here is another one, and here is 47. And see, there have two types of the algorithm you can select to change the gross area. The first one is the scaling the subtractor. It means that they will increase or decrease the size of each subtractor to make the final generated design satisfy the gross area requirement. But you can also change the maximum building, for example here. The building will be a little bit larger or smaller to satisfy to find the best solution to can the solution have the gross area close to the target area, like this one. So all right, let's move to the next section. Is the curtain the facade type. The facade type means that what types of the building facade you want to be, because this model is designed to connect it to some building simulation to like the Diva or the Ladybug. So they usually the simulation solver will require you to define the different parts of the building, for example, the floor, the roof, and the windows or the opening and the walls. So you can define two types of the wall, two types of the facade in this model. But usually you can define your own facade generated algorithm when using the EvoMass. So if you change the types, you can see that they will have some change in the facade. And here we can show you what is the difference. So here you can see this is like the straight opening in the regular building. And if you change to the curtain wall, and they will have a large the opening on the facade. All right. So let's move to the next part of the algorithm. The next part of the algorithm is that the attractive point, and you can actually set a point here, and this attractive point can interfere this subtractor, and they will make the subtractor closer or away from this subtractive point. You can change this value to find which number or the value of the interfering factor will satisfy your need. And also you can define some like the ground floor steel and the middle floor and the roof, which means that this subtractor will be only allowed to generate in certain part of the building. For example, if you disable this two one, and you will see this horizontal subtractor will only show up in this part of the building. So this can help you to redefine or to constrain the solution space for the optimization algorithm to search for, and exclude some design you don't want the model to generate. Let's see the other option, like this one. They will only cup the building in the top of the building volume, but the the bottom part of the building will be preserved. All right, let's move to the next operation. So here we will show some. All right, so it is similar to the additive one, and you can define the cutting boundary of the building. For example, if you click here and set the parameter, and you can see the building will be only generate within the boundary you define. And similar, if you want to use like in some cases, if you define this like, for example, the podium of a high-rise building, so you can define a box-like high-rise building along with this part of the building volume. So you can click here and to generate. So this the adding boundary will be also generated alongside with the model. So you can also connect this this part of the model to the simulation solver to calculate the whole performance metric in the optimization process. Let's hide this. And then maybe the last one of the operation is the fixed void. Fixed void means that you can define, similar to the cutting boundary, you can define which part of the volume not cannot be generate any of the, you can cup the building in some fixed position in the whole volume. You can create some solution like the L shape or the C shape building meshing. For example, we can set here. Here you can generate a L-shaped building like this. Yeah. And you can also, this means that the 0, 0 means that here is a 0, 0, and the 4 means that they will have a 4 column script in X direction and a 4 column script in the Y direction. So if you change this to, for example, 3 and 3, and then this 4 by 4 empty space will move to this a little bit center to the middle of the building meshing, like this one. So you can see this rectangle will be always cut in the building. All right, let's disable this. Oh, I forgot to say another very useful function here is that the boundary constraint. The boundary constraint means that how is this vertical subtractor can break the boundary of this building. For example, let's make this to 0. So you can see that all these void, or we can see is like an atrium is enclosure in the building massing. So if you want this void can be break through the edge or the boundary of this building massing, you can disable the boundary constraint. So in this case, you can find some open voids in the building massing, which can, for example, to expand the solution space by introducing some like the building massing with L-shaped floor plan, or even this will cut the building into two separate building massing entity. Another function is relative to this one, and also the adding additive one, is that the save and this part is all about the operation of the geometry, but another useful function is the save and load function here, because usually you have to collaborate with other colleagues. So if you sometimes have some errors in the grasshopper file, and you will find this setting will be missing. So this algorithm provide you a function that you can save all the setup in here and then you can to send this setup file to your colleague, and then your colleague can load this setup and to regenerate all the design in the optimization process. So for example, you can save here, for example, just the setup file. And you can see here is a 402424. Let's change some of this parameter. Just as I said, still have some bug I didn't find. All right, you can see the whole design is the whole building volume is defined to the new based on this new setup, and then you can load the setup you say, so it becomes the original one. We need to find some bug didn't find. So this function there is maybe have to check some more bugs in the algorithm, but I hope I can fix these bugs in the next version of the EvoMass. So this is all about the subtractive model. Thank you for watching this tutorial, and thank you for using the EvoMass. See you next time.